Okay, so good morning. This video is the continuation of what I have posted previously regarding the conversion to decimal to binary. So this is also showing to you the two methods of how to convert decimal to binary. Somehow along the way you will also be able to know how to convert binary to decimal or vice versa. Again, there are two methods. The first one is performing short division by 2 with remainder, and then the other one is descending powers of 2 and subtraction. Again, it is best that you will always condition your mind that decimal base 10 has 10 possible values. I have repeat this again and again, but I just want you to condition your mind or be innate in your mind that decimal value base 10 has 10 possible values, which is 0 to 9 for each place value, in contrast with the binary base 2 that has 2 possible values only, represented by 0 or 1 for each place value. Since in my previous video, binary system is the internal language of electronics computer, it is of course important for ComSci students or for any aspiring programmers that you should understand how to convert decimal to binary and vice versa. So the first example, in order for us to convert decimal to binary, let's convert 156 base of 10 to binary using the first method, which is the performing smart division by 2 with remainder. So let's start. Let's see, 156 base 10 to be converted to binary. So what are we going to do is to use or to perform this by using a short division by 2 with the remainder. Okay, so 156 divided by 2, of course, is 78. So we're gonna put here remainder. So of course, there's no remainder because this is a whole number. We're gonna put 0. So 78 divided by 2, this is 39. So there is no remainder also, so this becomes 0 for the remainder. So 39 divided by 2 equals, the answer is 19.5. So this becomes remainder, so we're gonna put here 1. So we have 19 divided by 2, which is of course 9.5. So this becomes remainder, so we're gonna put here 1. So we have 9 divided by 2. This is of course 4.5. This becomes remainder. We have to put this 1. And so 4 divided by 2, of course the answer is 2. This become a whole number now, so there's no remainder, so that becomes 0 or off. So we have 2 divided by 2. This is of course 1, so the remainder is 0. This becomes off or 0. Now 1 divided by 2, obviously this is 0.5. So this becomes 1. So in order for us to get the binary value for the 156 decimal base 10, we're gonna put, this is LSB or the least significant bit, and this is the MSB or the most significant bit. So if we're going to write this in a binary value, this becomes 1 0 0 1 1 1 0 0 base 2. So this is the answer Good morning again. So to proceed with the method or the two methods in order for us to convert decimal to binary, I'm going to show to you the second methods in order for us to convert decimal to binary. So the first one that was being introduced to you earlier is the short division by 2 with remainder. So the decimal value is 156 and it arrives in the binary value to 1001100. So to continue, I'm going to use the same decimal value 156 base to the power of 10, and then we are going to see if we can come up, or we are going to come up with the same binary answer, or the same binary combination. Okay, so it really helps. Again, it really helps if we get familiarized with the power of 2. So before that, I'm going to write here the base to the power of 2 combination. So 2 to the power of 0, we have 2 to the power of 1. We have 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7, 2 to the power of 8. Actually, I just want to have a disclaimer. Since I'm always writing this one, I'm actually repeating things again and again because I want that to remain in your mind, or to condition your mind to practice this quite a lot of times, because there are times like 2 days or 3 days or 1 week after, if you're not practicing this, you might really forget how to solve these simple numbers. So practice, and then just always remember the base to the power of 2. So the value for the 2 to the power of 0 is 1. 2 to the power of 1 is, we have 2. 2 to the power of 2 is 4. And then we have 8 here. We have 16. We have 32. We have 64. And then we have 128. And then we have 256. Okay, so if we are going to use the method power of 2 and subtraction, you have to remember that the number that is being converted, you have to see to it that the number that you are going to solve with the power of base 2 must be the next highest number, must be your number here with a big power base to the power of 2. So since the next highest number under 156 is 128, so we're gonna erase this one. Okay, so now we're going to start, because the number is actually, these are just the numbers that actually comprises with a value of 156. So we're gonna start with 156. The next highest number under 156 is 128. So before that, since we got this number already, we're gonna put here 1. So 2 to the power of 7, if this is switches, 2 to the power of 7, the switch for this is being turned on. So 156 minus 128, that would be 28. Now 28, gonna put here 28. What is the next highest number under 28 with the, so we have 28. So since the highest base of 2 value of 28 is 16, we're gonna put here 16. Okay, so we're gonna put here 1, since the next highest number under 28 is 16. Okay, so the answer for this is, of course, 12. So you're gonna put here 12 minus, so what is the highest number, or base to the power of base 2, highest number under 12? So we have 8. So you're gonna put here 1 and then minus 8. So this would be 4. Okay, so now we have 4. Okay, we're gonna write here 4 minus, so what is the number, highest number under 4? Well, of course, we have the equivalent number, so we're gonna put here 4. So the answer for this is 0. So we're gonna stop it from here. We're gonna put here 1. Now, in order for us to get the correct combinations or the complete combinations of what will be our answer for the binary, let us put it this way. So, since 64, we don't arrive to the answer of 64 using the power of 2 and subtraction. We're gonna put here 0, so with the 32, so with the 2, and so with the 1, or the 2 to the power of 0. So, if you notice, all of this that is being subtracted are actually the 1. So, if you consider this as switches, these are the switches that are being turned on. See? These are the switches that are being turned on. Now, to complete the combination, so therefore, our conversion of 156 base 10 is equals to 1, 0, 0, 1, 1, 1, 0, 0, base 2. So if you notice, we have the same, or we have actually arrived with the same number. Different method, but the same result or the same output. So therefore, you can actually use any of the method as long as you arrive with the correct answer. Just choose which method that works best for you or that you are comfortable with. Okay, so if you have any questions or clarifications, please let me know. And also, I hope that this presentation helps you in solving decimal to binary. In the same way that you can actually study more and practice more, you can actually somehow get the idea on how to convert binary to decimal as well. Okay? So thank you everyone and have a great day ahead.